keep forgetting things because I'll be just into the problem and be focusing on that. I forget many times to just switch on the recording. Okay, if I forget, please do remember me. Okay, now, yes. Okay, from the basic, I'll be explaining
Minus
all the things
35,000
once again.
minus
Okay, give me the answer, Karthik. What's the answer?
minus 35,900.
Minus 35,900
900.
kilo.
Yes.
Everyone got the same answer, guys? Any change, positive,
Yes, sir.
negative? Because the positive, negative plays a very
Yes,
important
sir.
role in first law and second law. Okay. So until now, what we have done, so in a question, many where has to be found out. Like sometimes he had given the value of Q, he had given the value of W. I need to calculate the value of delta E. So for that, I use the principles of first law of thermodynamics, which says for the cyclic process at a cyclic integral of Q is equal to cyclic integral of W. This can be applied when you're applying for the whole cycle. So when you're applying for the whole cycle, that is for the cyclic process, you can use cyclic integral of K is equals to the cyclic integral of W. And for the non-cyclic process, suppose if you are applying for the single process, then you can use dk is equals to dE plus dW. So using this particular equation, when you apply for the A to B, when you apply for the A to B, it seems as the heat flow from A to B is equals to change in internal energy from A to B and plus work done from A to B. Since Q is given, you have substituted. Since W is given, you have substituted and you have calculated what is the change in internal energy for the process A to B. So that is how you have filled it up thus. Okay. Secondly, same thing. So Q from B to C is given, W from B to C is given, and you have calculated what is the value of the change in internal energy with the same application of first law of thermodynamics. Even it goes same with the process C to D, but here he has given the value of the E, he has given the value of Q C to D. You are supposed to find out what is the value of W C to D. Okay, since all these three parameters were easy to find out, and now I have to calculate what are the parameters for the D2A. But D2A, nothing is given, like heat flow is not given, workflow is not given, change in internal energy is not given. So what I have done, I have used the information which is given in the problem statement. He says during cycle, the sum of the heat transfers is 170 kilojoules. That means give A to B plus this plus this plus this plus this. So when you add all this, the sum is equal to the 170 kilojoules. Be very careful about the units. He has mentioned it as kilojoules, and all other units are in the kilojoules per minute. So be very careful about that. So what you have to do in order to convert kilojoules to kilojoules per minute, he has given the additional information that the system completes 100 cycles per minute. That means you have to multiply 170 with 100 cycles, so your unit corresponds to kilojoules per minute. Okay, so that is what we have done at the last. So we have taken it as minus 17,000 kilojoules per minute. You know the value of A to B, B to C, C to A heat flows. So just have grabbed those values and calculated the value of Q D to A as minus 35,900. Okay. Any doubts until now? Any doubts?
No, sir.
No, sir.
Okay. Now, in order to calculate the value of E from D to A, I have something very important statement. Note what you have to note it that always, always cyclic integral of property. The cyclic integral of property is zero. That means Suppose here it is d cube is equal, if you when you apply the first law, so it is d cube is equals to dE plus dW, is it? When I apply the cyclic integral for the whole thing, that is cyclic integral of cube is equals to cyclic integral of E plus cyclic integral of W. Okay, what he does, he says the always the cyclic integral of a property is 0. See, Q is not a property, it is a path function, and W is not a property again because it is a path function. Whereas, what about energy? Energy is a property of a system. Even we have proved in some sort of derivations also, right? Always do remember it. Energy is a property. That's why when you have a cyclic integral of a property, then this could be 0, and you will be resulted with the first law applied for a cyclic process. Got the things, that is have cyclic integral of the heat flows is equals to the cyclic integral of the work flows. Got the point? That's why always the cyclic integral of a property is 0. So using that particular point here, cyclic integral of a property is 0, what I can write it as E A to B plus E B to C. Again, it is not just E, it is change in E. So plus change in E from C to D plus change in E from D to A is equals to 0. I think 3 are known and 3 has to be found out. Let me check. Yes. So you know the value of A to B, B to C, and C to D. We have to calculate what does D to A. So just substitute the values, guys. Give me the values. D, E, A to B. Change in internal energy from A to B.
Minus 2170.
Minus 2170. Okay. Plus DE from B to C.
21,000.
21,000. Plus DE from C to D.
Minus 36,600.
Okay. Minus 36,600. DE from D to A has to be found out. So just give me the value. This will also be in kilojoules per minute. See, units are very, very important. Be careful.
17,770.
Okay, 17 positive value.
Yes, sir.
Yeah,
Positive
positive.
value.
17,770. Okay, fine. So, kindly just update me the value so that I can update back here. Okay. What are the values we have found out? We have found out the value of Q from D to A. What is that value? What is that value? Q of D to A.
Minus 35,900.
Minus 35,900. And W D to A, no, delta E, that is DE from D to A.
17,770.
17,770. Okay, so since Q of D to A is known, Q of D to A is known, and DE, change in internal energy from D to A is known, I think you can calculate WD to A applying the first law for the process D to A. Can you do it? Apply the first law
Yes,
for
sir.
the process D to A. So apply first law for process D to A. So if I apply, what does it say? Cube D to A is equals to change in internal energy from D to A plus WF D to A. Okay. So change in internal energy, it is just here. I can write it. straight away. And Q D2A is minus 35,900. So it is minus 35,900 plus W D2A. So W D2A is how much, guys?
Minus 53,670.
Minus 53,670.
70.
Okay. Minus 53,670. Okay. I'll just update this back. Minus 53,770. Okay. So there ends your problem. Now, is the problem done? Anything else should I calculate? So he has asked to complete the table. I think we have completed the table with all these values which I have calculated. This one, this one. Later we have calculated this one. Later we have calculated this, this, and this. So I think we have completed the table. And compute the network output in kilowatts. So network output, he says, so just add the values here. So all these values you must add, okay, to give you the network output.
Sir,
So, yeah,
I got the answer is 53,670. I'm not sure.
which one?
Work done. Work.
Network done or D2A?
No,
D2A, I guess.
Yes, sir.
DTA.
53,670.
Okay. Then,
I
okay.
told the same, sir.
Yeah, yeah, yeah. I heard it wrong.
Okay.
So it's 670. Okay. Fine. What I was doing? Yeah. So you need to calculate what is net work done. So net work done for the cycle is what? WA to B plus WB to C plus WC to D plus WD to A. You have all the values. Give me the value of net work done in kilojoules per minute where it completes the problem.
17,000. Minus 70,000.
Minus 70,000,
17.
17,000. Okay. Everyone got the same value?
Yes, sir.
Okay. Okay. Understood the problem? Any doubts in this? It's
No,
just
sir.
the application of the first law. Okay. It's a simple problem. Any doubts in this?
No, sir.
Okay.
Sir,
Yes, Shabit.
joule, this watt is joules per second, no, sir.
Yes.
So we have to convert minute into seconds.
Exactly. So, okay, fine. Good point, Shabit. So he has asked us, he's asked us in kilowatt, is it? So just convert this thing. So minus 17,000 kilojoules per minute it is. Okay. So 1 minute is equals to how many seconds? 60 seconds. So I would be writing it as 17,000 divided by 60. It would turn into kilojoules per second here. Okay. But joules per second is what? Joules per second is watt. So it would turn into kilowatt. So give me the answer, the final answer. Good point, sir.
minus 283.33.
Minus 283.3. Okay. Anything else left? I think covered, I guess. Yes. Any doubts here?
No, sir.
And those who did not give their review in the last class, I asked the review, not the review, yeah, feedback from every individual. So just reported the same thing. So just stay, those who did not give their feedback in the last class, just stay for a while till the class end, and others can leave, okay, after I take the attendance. Wait, man, I'll call your name, Nartan. Just wait. So today will come from the bottom. Numan? Meanwhile, have you done taking it out?
Yes,
Taking
sir.
the question is done, right? Okay. So meanwhile, try to copy this. Okay. This will be solved in the next class. If you feel like solving it, just try it. Okay. I would be very happy that if you solve it. Okay. Numan Asati?
Yes, sir.
Okay. Muhammad Amin?
Yes, sir.
Adarsh P?
Yes, sir.
Varun? Rohan Pradeep? Rachan? Sandesh? Nilesh Markal?
Present,
Sir,
sir.
Prajwal, sir, you missed morning.
Prajwal Hegde. Okay.
Yes, I am
Is this your
present.
first class or what, man? Not
Sir,
Sandesh,
third
right?
class.
Oh, yeah.
Prajwal Hegde. Sir.
Yes, Mark. Okay.
Okay, thank
Sir, Ron
Hmm. Huh? Rohan Pradeep, where were you, man? Are you in the class?
yeah, yeah, I answered.
Okay, fine. Amit Sangoli? Varun, Vigneshwara, Sumant, Saurabha.
Present, sir.
Okay. Sriraj,
Present, sir.
Shravan Kumar,
Present, sir.
Shetty Tejas,
Present, sir.
okay, Shetty Sujay,
Present, sir.
Suman.
Sumant, I have called you, man. Okay. Mark. Shashank,
Present, sir.
Shahzad Abdullah,
Present, sir.
Sagar Sacharya, Shabad Ahmad,
Present, sir.
Ranjat, Ramdas, Rakshan.
Present, sir.
Ramdas present, sir.
Okay. Rajat,
Present, sir.
Satish,
Present, sir.
Prakhan, Omkar, Nitin George,
Present, sir.
Nashchat,
Present, sir.
Niharika,
Present, sir.
okay, Narthan,
Present, sir.
Nandish,
Present, sir.
Namita.
Present, sir.
Okay, so Nishchit is not there, right? Just for the confirmation, Nishchit. Okay. Nafa. And Suraj.
Present, sir.
Present, sir. Sir, Nishchit, present.
And Suraj. Where are you,
Present, sir.
Nishchit, when I called you? You answered or not? Nishchit.
I answered, sir.
Okay, pa.
I answered.
Yeah, okay. Muaz.
Present, sir.
Tausif Ali. Muhammad Sihab.
Present, sir.
Tausif Ali is there. Okay. Okay. What is this one? 4MT026?
Fazil.
17. Fazil. Okay. Fazil, right? Muhammad Fazil. Okay. Is he present? Oh, he's there. Okay. M. Karthik.
Present, sir.
Okay. Javel.
Present, sir.
Gautam.
Yes, sir.
Okay. Gautam there. Gaurav.
Present, sir.
Faizan. Faizan. Again, 17MT016. 17ME016.
I think it's Fahad, sir.
Binoy. Fahad.
So that's Fahad.
Fahad. Okay. Fahad is done.
Present, sir.
Binoy. Binoy is there. Chandan.
Present, sir.
Chandan. Ashwita.
Present, sir.
Ashwin. Ashwin K.
Present, sir.
Amrit.
Present, sir.
Present,
Amit.
sir. Anvit.
Present, sir.
Amrit and Anvit both are there.
Yes, sir.
Amit.
Present, sir.
Okay. Akshay R. Kotian.
Present, sir.
Muhammad Reza.
Present, sir.
Ashanul. Adarsh.
Present, sir.
Next, Abhinav and Abdul Rahman.
Present, sir.
Okay, guys, those who are given the feedback or review, whatever it is in the last class, they can just leave. Else, just stay for a few minutes. I'll just complete that thing.
Thank you.
Yes. Abhinav is there? Abhinav? Not there. Adarsh?
Yes, sir.
So give your feedback. So how are you feeling about the subject? And
The subject is good. In class is going good.
okay. So what should I write? Any issues in this subject understanding?
No issues. No.
Others, right?
Yeah.
Okay. Understanding better. Any other points, Adarsh?
No, nothing.
Okay, pa. Ashanul? Not there. Amit Yaslahari?
Yes, sir. No
Yes,
issues,
Amit.
sir.
So either you give a positive feedback or a negative feedback. No issues. I cannot write it as no issues.
The class is good, sir.
Either
No
of the two we have
problems in
taken.
that.
Okay, problem. Okay. Anything else?
No,
Problem
sir.
understanding?
No, sir. It's easy. Kind of.
Okay. Okay. Amrit. 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 Not there. Ashwita.
Yes, sir.
Yes, Ashwita.
Understandable. The subject is easy. No issues. No. It's fine.
Okay. Subject is easy, understandable. Any issues apart from that?
No, sir.
Okay, next. Chandan C. This is Binoy.
So it's a very nice subject, and I like the way you conduct the classes.
Thank you, man. Very nice subject. Interesting subject. I'll just add it up. Okay.
Yes.
That's fine. Next. Fahad. Fahad. Not there. Faizan. Okay, Faizan is done. Gaurav.
Yes, sir.
Yes, Gaurav.
No issues, sir. No issues.
No issues ಹೇಳ್ಬಾರ್ದು ನಾನು ಆಲ್ರೆಡಿ ಸೆಟ್ ಯು ಏನಾದರೂ
Subject
ಬೇರೆ ಹೇಳ್ಬೇಕು ಬೇರೆಯವ್ರು
easy,
ಹೇಳಿದ್ದು
sir.
ಹೇಳ್ಬಾರ್ದು
Subject.
ಓಕೆ ತಗೋ ಸಬ್ಜೆಕ್ಟ್ ಇಸ್ ಗುಡ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್
Understanding, sir.
ಅಂತ ಹಾಕ್ತೇನೆ ಓಕೆನಾ ನೆಕ್ಸ್ಟ್ ಗೌತಮ್
Yes, sir. Easy subject, sir, and interesting, very interesting subject.
ಸುಮ್ಮನೆ ಬಿಸ್ಕೆಟ್ ಹಾಕ್ಬಿಡ್ರು
Yes,
ಅರ್ಥ
sir. ಇಲ್ಲ
ಆಗ್ತಿದೆನಾ
sir. Yes, sir. ಅರ್ಥ ಆಗ್ತದೆ, sir.
ಓಕೆ ಫೈನ್ ಜವಿಲ್ದ್ ಆಯಿತು ಫಜೀಲ್
Yes, sir.
ಎಸ್ ಫಜೀಲ್
The subject is good, sir. Understandable. No problem.
See, you have to not copy the dialogues. Subject is good and understanding. Okay, fine. Okay, pa. Sihab is done. Tausif Ali. Okay, Muaz.
Yes, sir.
Yes, Muaz.
The subject is all good. At times I miss class because of my net issues. That's about
Okay,
it.
network issues. Missed some of the classes. Okay. Keep updating your notes, Muaz. That is very important. Okay. In Suraj.
Yes, sir.
Suraj system. Okay. Next is Namita.
Yes, sir. The subject is
Namita.
good, sir. Like much better than expected. It's easy to understand.
Oh, much better than expected. Okay.
Yes, sir.
So, what was your expectation of the subject?
As I've heard from my friends, I'm not sure about this one, but mechanical, like it's a headache.
Okay, fine. So, yeah, that's what I say. When you understand the concepts, when you go with the concepts, the subject becomes very easy. Okay.
Yes, sir.
That's good, Namita. Understanding the subject. What else? And concepts. Okay. Next, Nandish.
I have network problems, sir. Here.
Network problem. Okay. Have you missed any classes?
In the beginning, I have missed some classes, sir.
Okay. Missed some classes. So have you updated the notes, Nandish?
No, sir.
So just update the notes. That's very, very important. I say you have to write your own notes. Taking a copy of it or making a Xerox of it will not serve the purpose. Okay?
Okay, sir.
Where I was. Dun. Pratish Varna. Ramdas.
Sir, in the beginning, I've missed many classes due to my Wi-Fi issues. But
Okay.
now it's fine. From now, I'll be attending.
Okay. Wi-Fi issue, missed some
But
of
with
the classes.
But with understanding the subjects, I'm not having any problems, sir. Even though I've missed a lot of classes, you
Okay.
go at a slow and steady pace, which is
Yeah.
like very helpful for me.
That's great. That's great, man.
So even if whatever seems new on the screen,
Mm-hmm.
you make it easy for me to understand, sir. So yeah,
That's
I
great.
just have to complete my notes a bit. Yeah, I'm
Mm-hmm.
fine.
Okay, Ramdas. Thanks for that. Wi-Fi issue, missed some of the classes. Coping up very well. Coping up very well. That's next. Ranjit, no, there. Shashank, no.
Sir,
Varun and Vignesh. Who is this?
Shashank, sir.
Shashank. Are you there? Yes, ma'am, Shashank. Any problem with the subject?
No, sir. It's easy, sir. So, sometimes due to my internet connection, voice breaks. Sir.
Okay, voice breaking.
Sometimes it's not.
Okay, voice breaking because of internet connection. Okay, apart from that, Shashank?
No issues, sir.
No issues.
All good.
Okay, understanding the subject, right?
Sir.
Okay, pa. Next is Shetty Sujay. Shetty Sujay is done. No, Shetty Tejas.
Yes, sir.
Yes, Tejas.
So no issues, sir. Your teaching is very
No
appreciated.
issues. Oh, thanks for your appreciation, man. But I should write something which has to be reported to the department. Okay, what should I write?
It's a very nice subject, sir.
Very nice subject. Okay. Okay. Understandable. I'll just add it up. Understandable. Anything else? Nothing. That's enough. Good, Tejas. Learn happily.
Yes, sir.
Okay. Shravan Kumar, Sriraj, all done. Varun and Vigneshwar are not there. Sandesh. Sandesh. Okay. Adarsh P. Okay. Muhammad Amin.
Yes, sir. Subject
Amin.
is easy to understand.
Okay. Subject is easy. Is easy to understand. Then answer the questions, Amin, from the next class, okay? I mean to say the problems, the values, you should be interactive and give the answers very fast, okay?
Yes, sir. Sure.
Very good. Next, Numan Asaddi.
Yes, sir.
Yes, Numan.
Subject is fine. Other than
Okay.
that, I missed a few classes. I think
Uh-huh.
only two classes.
Okay.
That's
Missed
manageable.
few classes. Okay. Update the notes, Numan. That's very important, okay? Okay, na? And the basic concepts you have to learn, which I will be showing at the start of the class, is it? If you learn that thing, so first three modules is damn easy for you, okay?
Okay. Thank you.
Okay. Take care, huh?
Thank you.
Class.